All right, let's take a deep dive into chili peppers.
Yeah.
We've got some spicy source material here,
Uh-huh.
and we're going to go way past just like, is it hot or not?
Yeah.
Let's explore the chemistry of all those fiery flavors that we love
Right.
or love to hate.
Yeah, it's interesting because a lot of people think that chili peppers are actually hot, like
Mhm.
they physically have a high temperature.
Right, right.
But that burning sensation, it's all about how our brains interpret certain chemicals.
Okay, so it's like a trick, like a sensory illusion.
Yeah, that's a good way to put it.
So tell me more about these trickster chemicals.
Well, the chemical culprits behind the heat are called capsaicinoids.
Capsaicin.
And capsaicin is like the most famous one.
Okay.
So think of it as like the lead singer of the Spicy Sensation band.
So when I bite into a jalapeno and I feel that burn,
Uh-huh.
that's capsaicin messing with my senses.
Right.
But like, why? Why would our body react that way? Like, what's the evolutionary purpose?
Well, peppers didn't evolve to like torment our taste buds or anything.
Yeah, sure.
Capsaicin is really a defense mechanism for the plants themselves. You see, mammals like us, we tend to crush seeds when we eat.
Yeah.
And that's bad news for a pepper that's trying to, reproduce.
Right.
But birds swallow seeds whole.
Oh.
So peppers evolved a way to kind of deter mammals
Okay.
without bothering the bird.
That's pretty smart, those peppers playing the long game,
Yeah.
making sure those seeds can spread far and wide.
Exactly.
But how does capsaicin actually create that burning sensation?
Mm-hmm.
It's not really like setting our mouths on fire, is it?
No, not at all.
Okay.
It all has to do with how capsaicin interacts with our nervous system.
Okay.
These molecules bind to specific receptors called TRPV1 receptors.
TRPV1.
Yeah, and these receptors are found on nerve cells in our mouths and our skin.
Okay.
And these are usually activated by actual heat, like when you touch a hot stove.
Ah, so it's kind of like hijacking the system. Sending a false alarm to the brain saying,
Right.
fire, fire,
It's like, hey, danger.
when there really isn't any.
Exactly. It's a culinary smoke and mirrors act.
Pretty cool. So a simple molecule can trick our senses.
Yeah, it's really fascinating.
But obviously not all peppers are created equal, right?
Right.
Some are just a flicker of heat,
Uh-huh.
and others are like volcanic eruptions in your mouth.
Totally.
So that's where the Scoville scale comes in.
Yeah,
right?
yeah.
I've always been curious how they actually measure that heat level.
Mm-hmm.
It can't just be a bunch of scientists bravely munching on peppers.
Thankfully, no.
I was picturing like a contest.
No, science has thankfully advanced a little bit since then.
Okay, good.
Today, we use high-performance liquid chromatography,
Wow.
or HPLC, to measure the concentration of capsaicinoids in a pepper.
So that's a lot easier on the scientists.
Oh, yeah, definitely. Much less painful.
So the higher the concentration of capsaicinoids,
Mm-hmm.
the higher the Scoville heat units
Yeah, exactly.
or issues.
Yeah.
And the hotter the pepper.
That's right.
But I've also heard that some peppers, even with a high Scoville score,
Uh-huh.
might not taste as spicy as you would think.
Right.
So is there more to the story than just the heat level?
Oh, absolutely.
Okay.
There's a whole world of flavor complexity beyond just the burnt
Okay.
chili peppers. They're bursting with other compounds that contribute to these unique taste profiles.
Right.
We're talking fruity, smoky, citrusy, even earthy notes.
Wow.
It's a whole symphony of flavors waiting to be explored.
So a pepper can be like a screaming soprano on the Scoville scale.
Yeah.
But if it doesn't have the right backing band of flavors,
Mm-hmm.
it's not going to be a chart topper in the culinary world.
That's a great analogy. I like that.
Okay.
And that's why understanding these flavor profiles is so important,
Right.
especially if you're adventurous in the kitchen.
Yeah.
For instance, you might think that a habanero, which is known for its fiery heat,
Mm-hmm.
would be all about the capsaicin,
Yeah.
but it actually has this distinct fruity, floral flavor profile
Oh, wow.
that makes it incredibly versatile.
Really?
Yeah, you can use it in different cuisines.
Okay, so there's a whole lot more to chili peppers than just setting our mouths on fire.
Definitely.
But I have to ask,
Mm-hmm.
if you keep eating spicy food, will we actually become immune to the pain?
Ah, good question.
Can we trade our taste bugs to handle the heat?
That's where it gets really interesting.
Okay.
Repeated exposure to capsaicin can lead to desensitization.
Desensitization.
Which basically means that those TRPV1 receptors become less sensitive over time.
So they get used to it, like a spicy boot camp.
That's a good way to put it, yeah.
But does that desensitization affect how we perceive the flavors?
Ah, another good question.
The complex flavors that you were talking about.
That leads us into the intricate interplay between flavor and heat perception.
Okay.
We'll dive into that in just a bit.
Sounds good.
All right.
Yeah.
Okay, so that desensitization process,
That's key to understanding how we experience those flavors,
Exactly.
both the heat and the flavor.
Yeah, so while capsaicin is setting off those alarm bells in our mouths,
Uh-huh.
all those other flavor compounds are working their magic too.
So it's like a sensory tug of war happening.
Yeah, I like that.
Capsaicin is like fire,
Mm-hmm.
and the other compounds are trying to add some nuance
Right, exactly.
and some complexity.
And that balance between the sensations,
Yeah.
that can vary a lot depending on the pepper
Okay.
and how it's prepared.
So it's not just how much capsaicin,
Uh-huh.
it's the timing,
Right.
the intensity of the heat in relation to those other flavors.
Yeah, it's like a carefully choreographed dance on our palates.
Tell me more about those flavor compounds.
Okay, so we're talking about a whole bunch of chemical compounds,
It's
each one contributing its own little note to the whole flavor.
Okay.
So things like esters, aldehydes, and ketones,
Okay.
these are the same types of compounds that give fruits their sweetness,
Right.
flowers, their fragrance,
Uh-huh.
even freshly cut grass, its smell.
Wait, so those same compounds that make a rose smell so good
Yeah,
are also responsible for the smokiness of a chipotle pepper?
that's right.
That's pretty wild.
It is, isn't it?
Like, nature is using the same ingredients to create this huge variety.
Exactly, and the combinations are basically infinite.
Wow.
Some peppers might have high concentrations of esters,
Mm-hmm.
which give them a fruity and floral aromas.
Okay.
Others might have more pyrazines,
Hi, wait.
which have those roasted nutty flavors.
Like in a poblano?
Yeah, like a poblano.
Okay.
And some might even contain sulfur compounds.
Okay.
And those can create savory or garlicky notes.
So much chemistry in a single bite.
Right. It's amazing.
How do those flavors interact with the capsaicin?
Well, it really depends on the specific compounds
Okay.
and their concentrations.
Okay.
In some cases, they can actually enhance the heat.
Really?
Yeah, for instance, some esters have been shown to increase the sensitivity of those TRPV1 receptors.
Oh, so it's like a tag team.
Yeah, you could think of it like that.
Some flavors amplifying the heat.
Right, exactly.
You mentioned that some compounds can have a mitigating effect.
Right, so some compounds can create a cooling sensation,
Okay.
like menthol in mint.
Yeah.
And that can counteract the burning.
Okay.
Other compounds might round out the heat and just add more complexity, like the fruity notes of a habanero pepper.
Uh-huh.
Those help balance the heat. It's just a
Interesting.
bit more enjoyable.
It's like a culinary yin and yang.
Yeah, that's a good way to put it.
Heat and flavor constantly playing off of each other.
Exactly.
Are there any peppers that break the mold?
Well, there are always exceptions in nature.
Okay.
The chili pepper world is no different.
Okay.
One really interesting example is the Sichuan peppercorn,
Sichuan peppercorn.
which, despite its name, isn't actually a pepper.
Wait, what?
Yeah, it's a dried berry from the prickly ash tree.
Okay, so not all peppers are actually peppers.
Right, it can get a little tricky.
What makes the Sichuan peppercorn so unique?
So instead of that burning sensation,
Uh-huh.
the Sichuan peppercorn creates a tingling, numbing sensation.
Numbing.
Yeah, it's often described as ma la in Chinese,
Okay.
which translates to numbing and spicy.
That sounds more like a dentist visit
Right, it's very unique.
than a culinary experience.
Yeah, but it adds a whole other dimension.
What causes that numbing?
So the compound responsible, it's called hydroxy-alpha-sanchal,
Okay.
and it works completely differently than capsaicin.
Okay.
Instead of activating those heat receptors,
Uh-huh.
it interacts with sensory neurons involved in touch and pressure.
Wow, so instead of fire, it's messing with our sense of touch.
Yeah, it's like a temporary sensory illusion.
That's really cool.
It is, and that numbing sensation adds a really unique dimension to Sichuan cuisine.
Okay.
Creates this complex interplay of flavors and sensations.
We've gone from the burn of capsaicin to numbing Sichuan peppercorns.
That's right.
Pretty amazing how nature has this whole range of compounds.
It really highlights the complex ways that plants have adapted
Yeah.
and how those adaptations can lead to these amazing sensory experiences for us.
This deep dive has really opened my eyes
Good.
to the diversity of the chili pepper world.
It's a fascinating world.
I feel like there's even more to discover.
Well, we've explored the chemistry of heat and flavor,
Right.
but we haven't touched on the genetics of it all.
Genetics.
Yeah.
Are you saying our love for spicy food is written in our DNA?
That's a great question, and it leads us into a whole new realm of scientific exploration.
So genetics might play a role in how much we love or hate chili peppers.
Yeah, it's a really fascinating area of research. It helps explain why some people can handle so much heat
Yeah.
and others just can't.
Like some people I know can just eat goat peppers like candy.
Right.
And I'm over here sweating after one bite of a jalapeno.
Exactly, and it all comes down to our genes.
So is there like a spice gene?
Well, not exactly. There's
Okay.
not one single gene that determines it all.
Okay.
But variations in our genes can make us more or less sensitive.
To
to
capsaicin.
capsaicin and other compounds.
So it's not like an on-off switch.
No.
More like a dimmer switch.
Yeah, that's a good way to think about it.
Okay, but how does that work?
Well, remember those TRPV1 receptors?
Uh-huh. The ones that capsaicin binds to.
Right. Well, our genes can actually influence how many of those receptors we have
Okay.
and how sensitive they are.
So some people just have more of those receptors?
Yeah, and some people's receptors are just more reactive to the capsaicin.
That makes sense.
So they feel a much more intense burning sensation.
I guess that's why I tap out so early.
It could be.
What about those other flavor
Oh,
compounds?
yeah.
Do our genes affect how we taste those too?
Absolutely. Our genes can influence how we perceive all kinds of tastes.
Sweetness, bitterness, all that.
Yep, all of it.
And chili peppers have that whole orchestra of flavor.
Right.
So our genes must be playing a big role.
Yeah, they can shape our preferences for specific peppers
Okay.
and specific flavor profiles.
So kind of like how some people think cilantro tastes like soap
Exactly.
because of their genes.
It's very similar. Some people might be genetically wired to love habaneros
Okay.
or the smokiness of chipotle peppers.
It's like our DNA is giving us a flavor guide.
That's a great way to put it.
This is pretty amazing, this whole genetic side of things.
It really is, and it's opening up some really exciting possibilities.
In the culinary world.
Yeah, definitely.
Like what?
Well, imagine personalized menus
Personalized menus. Okay.
based on your DNA.
Is that even possible?
It's not as far off as you might think.
Okay.
You could go to a restaurant and have a menu designed just for you,
Wow.
based on your genes.
So they'd know exactly what I'd like.
Exactly, maximizing your environment.
And no more accidentally ordering something way too spicy for me.
Right, no more surprises.
But are there other applications?
Oh, yeah, absolutely.
Uh,
Like what?
Well, think about global health challenges.
Okay.
We could use this information to make food that's both nutritious and delicious.
Okay. And tailor it to different populations.
Wow, we started with just chili peppers.
It's amazing how it all connects.
And now we're talking about solving health problems.
Right.
That's crazy.
It really shows that even simple things can be incredibly complex
Yeah.
and full of potential.
This deep dive has been amazing.
Good, I'm glad.
From capsaicin to flavor compounds, the Scoville scale, even genetics.
We've covered a lot.
We really have.
It's been a pleasure exploring all of this with you.
Likewise.
Whether you love spicy food or not,
Mm.
there's always something new to discover.
That's true.
Keep those taste buds tingling and never stop asking questions.
Couldn't have said it better myself.
Great.
Well, that wraps up this spicy deep dive.
Yeah.
Thanks for joining us.